All right, so let's get started. All right, so here we're going to be in section 6.3, Systems of Linear Equations. So here we're going to define a matrix. So we're going to define a matrix here. An m by n matrix is a rectangular array of numbers such that it has m rows and n columns. And so the dimension is rows by columns, so it's row by column. So this is an n by n matrix. For this one, we have two rows and three columns. And so we say this is a 2 by 3 matrix, just in case you're wondering. Here's just a concrete example. So when we list it, we list the entries. The first entry is the row. So this is the third row first, and the second entry is the column. So this is third row, first column. This is, that should be a 2. So this is second row, third column. This is second row, second column. This is third row, second column, and so forth, right? And so we say it's the ith row in the jth column for the entry aij. And so this is just what a matrix is. We'll mess with this more later, but for now we're just going to use it as a short way of holding our matrices. And so here we're going to write as an augmented matrix. So a linear system can be written as an augmented matrix. So here I'm going to write all my x's in my first row, all my y's in my second row, and all my constants in my third row. For the and we just keep, and then my first equation goes here, and my second equation goes here. We're mainly going to use this for 3 by 3 systems. So I'm going to mainly use this for a 3 by 3 system. And so let me show you how this works. And so what you're going to do here is you're just going to draw a little line. And so here our first row, so all my x's go in the first row, so it's a 1, 4, or first column, and a 3. All my y's go in the second column, so that's -2, 2, and 2. And so you're just doing the coefficients. Here, it'll be 3, -1, -5. And notice we keep the negatives with the coefficient. And then we'll have 7, 42, and 5. Here, if we don't have an entry, we're just going to put in zeros. And so here we have 3. We have no x and no x, so we'll have 0 and 0. Here I'll have -2, 2, and no z or y here, so it's 0. And then here we have 1, -1. Please make sure to grab the negative. And then 5. And then we have 2, 1, and 15. Notice if there is no variable, we don't have a row for it. So even though this is 3 rows, it's -3, 24, 5. And here we have -2, 1, -2. And then here we have 2, 7, and 2. Okay, so go ahead and try to write this as an augmented matrix, putting where stuff goes in that, and then I'll show you the answer in a second.
Yeah, you stop eating the breads.
All right. So what you get for the first row, or the first, that's just, I'd try, but I'm not sure how. Do you want to put this in chat? So let's do it row by row. Okay, so let's just do this row by row. So the first row should be 0. Oh, okay, so the first row is 0. Let's just do this correctly. I guess I've always doing columns. Let's just do this by column. Let's do it by column. I said, let's do this by columns. So the first column you guys have correct here is 0. So if some people are rowing, so 0, 1, 3, 1. The next row would be 1, 0, -7, 3. And the last one would be 3, 3, or 33, 42, 0, and 125. Okay. All right, so I'll leave that up for people to copy. So wait, which is row, which is column? Oh, here. Let me just rewrite this real quick. Let's just rewrite it. Let's rewrite it nice and clean. All right, so here, if we went down by rows, it'd be 0, 1, 33, 1, 0, 42, 3, -7, 0, and then 1, 3, 125. Okay. You can state these as either rows or columns. All right. Okay. Let's go to the next. So yeah, so the vertical, so this is a column and this is a row. Okay. This is what this is so we go down, if we're going vertically, it's a row, or a column, sorry. We go horizontally, it's a row. All right. Oops. We already solved it. let's not. All right, so here, here are row operations. So let's get rid of this. Let's go with a nice, oops. Uh-oh, I wrote some of this on the empty layer. No. How much did I write on the empty layer? The first couple steps. All right, we'll just re-empty the layer. What's this? Bam. Ha! Ta-da. It's a new layer. We're good to go. All right, so here, what we can do now is we can interchange one row with another. Same thing as interchanging equations. We can multiply row by a non-zero constant, and we can add a non-zero multiple of one row to another. So here we're going to solve the system, same as before, with the same goals, right? And remember what the goals are. We're going to try to get it to look like, let me actually show you here. Let me go ahead and get rid of this. All right. This is our goal. We're going to start with an array of numbers. We're going to try to get a 1 up here, and then we're going to put zeros here and here. And then we're going to try to put a 1 here, and we're going to put a 0 here, and we're going to put a 1 here. And then we're technically done. Technically, you can solve it at this point, and I'll show you how to do that. But if you want to keep going, the next step is put a 0, 0 here, and then a 0 here. So you're always going to do it. So reduce row echelon form or row echelon form. You don't need to know this. I just put it in for information, but go ahead and skip this. Your homework never asked you about it, so go ahead and skip this for now. It didn't ask us this in reduced row echelon form. I could have sworn I was going to, but it didn't. Just memorize this. Yeah, next time we do this class, they'll put it in this just to make sure I'm a liar for the next. But just follow this and do this in this order. In this order. Do this in this order. This is our goal. We're going to do it in this order, and if you do it this way, it always works out, and you always get an answer. Well, you always get to the point where you know your solution. So if it's none, all, or any. Okay. So let's go back to here. So let's start crunching through this. All right. So here we have, so the first thing we're going to do is we're going to put this all into an augmented matrix. And I'm going to fill this out by rows this time. So it'll be 1, -1, 3, 4. That's our first equation. Our second equation is 1, 2, -2, 10. We have 3, -1, 5, and 14. So it's just the coefficients here. All right, so now we're going to, I'm like, why does that not match what I have here? So let's go ahead and solve this. And so the first thing, so what's our first step? Let's go to this. Our first step is we want a 1 here. Do we have that goal? Yeah, we have that goal. So we're already done with this step. Our next step is to put a 0 here and a 0 here. So we want a 0 and a 0. Okay. So I'm going to do this for the sake of the very first time we're doing this. We're just going to do this. So this is the same when we had equations. I'm going to do it one step at a time. Oops. Let me do the first step first. I'm going to do this one step at a time. So I'm going to take -1 of this row and add it to this row. All right, and so we have -1 times 1. So the first row is the same. So we just write that down. Second row is the same. So we're just going to write that down. And then for this one, we're going to take -1 times 1. I get -1. Add it to 1, I get 0. We're going to take -1 times -1, because +1. Add it to 2, I'll get 3. We're going to take -1 times -3. Or -1 times 3 gives us -3. -3 added to -2 is -5. And then here we'll take -1 times 4, add it to 10, which gives us 6. Okay, so just take this, multiply by this, add it to this. This multiplied by this, add it to this. This multiplied by this, add it to this, and so forth. Same thing we did before. Now instead of just writing all these x's, because notice these x's are not necessary to write. The y's are not necessary to write. The z's are not necessary to write. This equal sign is not necessary to write. It's always there. And so this is just a way of doing the same thing we did the last section, just a lot cleaner, in my opinion, because you're only looking at the numbers. That looked like a 3 before I mess it up. All right, and so we got a 0 here, and now we want a 0 here. In order to do that, I'm going to take -3 of this row and add it to this row, because that will give me a 0 here. So basically, I negate whatever the coefficient is here. All right, and we'll do that multiplication. So here, I didn't change the first 2 rows whatsoever, so I'll just write those down. So 1 - 1, 3, 4, 0, 3, -5, 6. And then we'll have 3, 1, -1, 5, -14. Oops. Oh, we changed that row. We got to do that now. So here, -3 times the 1 will give me -3. So -3 plus 3 is 0. What's this one right here? Go ahead and put that one in chat. This guy here. Yeah, I can do that. Put that one in chat, and as I mark our friend who came a little later. Yeah, the answer there is 2. What's the next one after that? So here, this is 2. What's this one? And this one? Go ahead and finish out the row for me. I want you to try. That way, it'll make sense when you do it. So what are the next 2 entries? Here, I'll give you what the next one is. So here I have -3 times 3 will give me -9. -9 plus 5 gives me -4. So what's this next entry? What's my constant here? It'd be -3 times 4. That's going to give you something, and then you do something. So what's this last step? That's right, 2. Okay. All right, so here. So now let's see where I'm at. I've done this step. I've gotten my 2 zeros. So my next step is I want a 1 here. That's the next step I want. Well, I could divide by 3, but then I have fractions. Nobody wants fractions. Trust me, no one wants fractions. Will you have to see fractions eventually when you do this? Oh, I'm sure, right? I'm very sure. But notice if I divide this by 2, this becomes very cleanly 1. So for the very first time, we're just going to swap rows, right? We're going to interchange 2 rows, and that's something I'm allowed to do. You can't switch columns, but you can switch rows. So I will just switch the rows. Now, why would I do that? Will become very apparent in a second. All right, so now I just want this to be nice and clean. So I'm going to multiply by 1/2. Instead of writing multiplying by a half, even though technically that's what I'm doing, I always just say divided by 2. Just, okay. So our next one will be 1 minus 1. So all I did here was switch rows. Why did I switch rows? Well, I want a 1 here. And if I divide by 3 to get the 1 here, I'm going to get a fraction and not a fraction. I don't want to do a fraction. So I switch rows since this divides nicely by 2. 1 minus 2, 1. 0, 3 minus 5, 6. All right. Let's go back to our algorithm. So we have a 1 here. The next thing I want is a 0 here. So let's do the 0 here. So I want a 0 here. In order to do that, I'm just going to add minus 3 of this row to this row, or just minus this number right here, because this is 1, and therefore when you negate this number, whatever it is, will always work. All right, so let's write that up here. Let me zoom out so I can see it. So the first two rows I've done nothing with, so I'm just going to rewrite them. 0, 1 minus 2, 1. And then we'll have 0 here. Let's go ahead and, so negative 3 times 1 gives me minus 3. Added to 3 gives me 0. Negative 3 times minus 2 gives me positive 6, plus 5 gives me 1. Negative 3 times 1 gives me minus 3. Added to 6 gives me 3. All right. All right. So here, once I have this, technically you can solve this. Remember what this means. Remember what this means, right? This means x minus y plus 3z is equal to 4, right? So here x, remember this is our x column, this is our y column, this is our z column, this is our constant column, right? So the constant, which we're using these, it's just what the standard is. And then what this one says is I have y minus 2 equals to 1, or minus 2z equal to 1, and here I have z equal to 3. And so technically, you can solve it at this point. You can just back substitute in. So this means this. Remember, it's just a way of encoding it so it's smaller, kind of like synthetic division, right? Where you encode it so it's just less work. That means that. However, if we finish the algorithm, we finish this algorithm here, we have less work to do. Trust me, I have less work. If we just finish doing what we're doing. So where were we at in our algorithm? We got a 0 here. So we got the 0 here. Do we have a 1 here? Yeah, we have the 1 here. So we move on to this now. I want to put a 0 here and a 0 here, and do it in this order. If you don't do it in this order, what happens? So let's pretend if I put the 0 here and didn't put a 0 here, when I move this back up, I'm going to destroy this 0, right? And so if you do it out of order, you just end up wandering blind paths that lead nowhere. I mean, you're not doing anything wrong, you're just not progressing forward, right? It's kind of like just always rowing on one side of the boat. You're just going to go in circles. So our next step is we're here. We want a 0 here and a 0 here. And so let's do that. And so that here, I have a 1 here, so I just need to add 2 this way. And then we just need to add minus 3 this way. So just take this coefficient and negate it. Doing that gives us the following: 1 minus 1. Negative 3 times this is minus 3 plus 3 is 0 by design. Negative 3 times this is 9. Negative 9 plus that would give us minus 5. Here we'll have 0, 1. We're going to add 2 of this to here. So 2 added to minus 2 is 0 by design. 6 added to 1 gives us 7. And then we have 0, 0, 1, 3. All right, so we've achieved this goal. And then the last goal is to put a 0 here. So we want to put a 0 here. And that's really simply just by adding this row to this row. And we have 1, 0, 0, minus 5, 0, 1, 0, 7, 0, 0, 1, 3. And then when I translate this over, this just means x plus 0y plus 0z equals, oops, I didn't change that, did I? This plus this gives me a 2. So, hold on, I gotta sneeze. So I don't. Okay, so x plus, so notice here, this plus this is 0, and this plus this is 2. So here I have 1. So x equals to 2, y equals to 7, and then z equals to 3. And so if you do this, you've completed your goal. In fact, you can just write down the answer from here. You can write 2, 7, 3. Okay? All right. So let me show you how to do. Let's do the next one. So let me let you copy this down real quick, and then we'll do the next one. All right. Just for happy time's sake, I will go on to the next one. If you missed a page, I'll post the videos after class. So yeah, I'll just post the videos after class. Okay, so let's do the next page. So here we've already done half this page. So let's just do one more problem. So we're going to follow this format exactly. And this program's designed to show you things, okay? All right, I'll catch you. Oh, I'll just mark you late now. All right, I got you, Siege. Okay. All right, so let's do the next one. All right, so this one, we're going to have to do all this. Just for your information, this is what we call row echelon form. So this is the row echelon form. And this is the reduced row echelon form. Okay, so oops. So because that satisfies, because the first number in a row is 1. Leading entries to the right of the row above it. So it means here the next leading the row above it, the next leading, the first one is here, is to the right, and all non-zero rows at the bottom. And then every row with a leading entry is a 0. And so that's how you get the reduced row echelon form. I wouldn't worry too much about it. So the first thing we want to do here, the very first thing we want to do here is to write this as an augmented matrix. So let's do that. So I have 4, 8, minus 4, 4, 3, 8, 5, minus 11, minus 2, 1, 12, minus 17. Okay. So here we've written it as an augmented matrix. So we're on this step right here. This is the step we're on. So here, we're at this step here, right? In order to get to my next step, I want to make this a 1. Well, can I divide cleanly by 4 here? Yeah, sure, right? So that's the first thing we're going to do. Divide by 4. And so I get 1, 2, minus 1, 1. That's a 1, not a 2. Then the rest of this is the exact same. 5, minus 11, minus 2, 1, 12, minus 17. All right. So which step am I on now? All right. Well, I have achieved this. Hold on. And it's a white. That's not going to help me. So here, I'm here. So where's my next step? Put zeros in, 2 zeros. So let's do that. Go back to my blue so I can write. So in order to get the 2 zeros in, we're going to negate this one. So this will be minus 3 of that. And we're going to negate this one. So that's positive 2. So we'll take 2 of the first row and add it to this row because we want a 0 here and a 0 here. So add some multiple of the first row to the second row, in this case minus 3, to get a 0 here. And then we're going to add some multiple of the first row to the third row to get a 0 here. In that case, it's 2. So we didn't change the first row at all. So let's go ahead and write that down. 2 minus 1, 1. Here, negative 3. So 1 times negative 3 is minus 3. Minus 3 plus 3 is 0. 2 times negative 3 is minus 6. Minus 6 plus 8 is 2. Negative 1 times negative 3 is positive 3. 3 plus 5 is 8. 1 times negative 3 is minus 3. Minus 3 plus minus 11 is minus 14. Okay, so go ahead and try to do this next row. Try to do the bottom row without me real quick. Okay. try to do that. And then when you have it, just write it into chat. I wanted to see if you guys are following or where you're lost at. All right, so we got a couple answers. Um, yeah, so let's do this slowly. So here, we're going to take 2 of this row and add it to this row. So it would be 2 plus minus 2 is 0. Because this is the first time it's a positive we've done this. Here, this becomes 2 times 2, which is 4. Add it to 1, I get 5. 2 times negative 1 gives me negative 2, plus 12 gives me 10. And then 2 times 1 is 1, and so that's plus that gives me minus 15. Okay. I just, yeah, be very careful what you do. All right, so here, so where are we at now? Let's use the, I don't know, the lavender color. So we're here on this step, right? So we're here on this step. So our next step here is to get a 1 here. Well, what's the easiest way to do that? Well, this divides nicely by 2, so let's just leave it and divide by 2. So we'll put this step up here. So I have 1, 2, minus 1, 1, 0, 1, 4, minus 7, 0, 5, 10, minus 15. All right. So here we are at this step. So now we are, I don't know, let's just use this maroon color, I guess. So we're here. All right. So I want you to do the next step without me. Figure out what you're supposed to do, how to do it, and go ahead and put it in. Because if I can get you to do one step without me, the rest I can trust you to do all the steps without me. So give this a try. All right, give it a try. Honestly, try it. If you're just sitting there kind of watching, thinking, "Oh, he'll put it up in a second," give it a try. Because when you do this on your own, you're going to be in trouble if you never do it. So, all right. Yes. Yes, that's what you're trying to do. Interesting. There we go. Okay, so we got 2 people with answers, so let's show it. Yeah, so that's the next step. So our next step is here, right? This is our next step. So here, I don't know, let's do this in, I don't know what color am I on. Let's do this color. I'm going to run out of colors, so I'm just going to skip the colors from now on, guys, but you get the idea, right? So here, the next step is to make this a 0. So how am I going to do that? I'm just going to take -5 and just negate this and add it to that. So, oops, this is a 1, 0, 1, 4, -7. And then we have 0. And then when we do that out, we get nothing. We get -10 because this becomes -20. And then we get +20 because this here becomes -35 plus, or +35 plus -15 gives us 20. Okay. Our next step is here. We make this a 1, so we divide by -10. So I have 1, 2, 1, 1, 0, 1, 4, -7, 0, 0, 1, -2. Okay. All I do is divide by -10. Anything multiplied by 0, 0. Yeah, so you can just skip everything. You can, so you don't need to worry about these. This is 0, this is 0, this is 0. So once it's 0, it's always 0 if you follow this order. Okay. Then we're here. I'm out of colors. That's fine. So we're here. Now, our next step is to get zeros here. So let's do that. So here, I'm just going to add up by -4, and then we're going to add up by, oops, that's a -1. Be very careful. I would have made, from then on, everything would have been wrong if I didn't have a cheat sheet in front of me. So be super careful. Because if you make a mistake like here, you have to erase everything you've done and go back to here and go forward. So you got to be very careful with these. Once I do that, I'll give you what the answers are. So here we're going to take 1, so it's 2. And I'm just adding 1 up this, so I'm just adding this row to this row, basically. So I get a 0 here and a -1 here. And then here I have 0, 1. I'm adding -4 of this row to this row, so this be 0, and then this becomes 1 because -8, so this becomes +8. This 1, then I have 0, 0, 1, -2. All right, and the last thing I want to do is I'm at this step. Now I want to be here, so I just want to make this row 0, and so I'm just going to -2 of this, -2 of this to this. And that gives us our very last one, which is 1, 0, 0, -3, 0, 1, 0, 1, 0, 0, 1, -2. And so, and then we just read off the answer. Our answer here is -3, 1, -2. And that's the answer. Okay, or x, because what does this mean? This means x is equal to -3, y is equal to 1, and z is equal to -2. That's how this reads. And just, and notice at any step, this means, let's check, say if I did this one, right? This step right here, that means x plus 2y minus 1z equals to 1. Y plus 4z equal to -7. And so remember what these originally mean, right? Or go back to this. Remember what they originally mean, right? This is just a shorthand, so I don't have to write x all the time, or y all the time, or this equal all the time. It's just a way of shorthanding it. And so, but this really means this at the end of the day, and this really meant this, okay? All right, so we only have one little bit more to go. Hi, it's all done. Get rid of this. All right, so here we're same things. And so what we have here, let's go ahead and do this. So here, if I have it in reduced row echelon form, and I have, I don't know, I'll just use stars, I guess, to represent numbers. So number, right? So if I have it look like this, there's exactly one solution. So I have a 1 and a 0, 1 and a 0. Oh, no, we'll make this look like a 0. Hey, you look more like a 0. There we go. Let's put this here. There we go. So, and this one has exactly one solution, and you just read it off. X is this number, Y is this number, Z is this number. If it has no solutions, eventually, when you do your reduced row echelon form, you're going to have one. Oops. And then you'll have number. Oh, hold on. That should be a 0. Number. And so you'll have this 0 equals in a number thing. Remember, that meant no solution. Okay. And if you have infinitely many solutions, basically what happened is one of your rows will 0 out. So here I have 0, 0, 0. And so if you have a 0 row, you'll have infinitely many solutions. Okay. So in this case, I am going to, we can put this into an augmented system. So let's do that. And then I'm going to teach you how to type it into a computer, especially for us being remote. That makes it super easy. If you ever teach this class online, you always will have this calculator available to you. Eventually, we'll go back to doing it by hand, and then whoever's watching these poor videos is like, wait, they could use a calculator? Yeah, they could. Right? I can almost hear it now. It's like, hey, when I reteach this class, it's like, I wanted to use a calculator. All right, so I'll show you how to do it in the calculator just so you can check your answers. Okay. Remember, for those who are taking this remotely, please do it by hand. Please do it in the calculator. Check that they're the same. Something good about 2020. Calculators for us all. Oh. I'm sure there's other good things. There's just so many not so good things, right? Oh, man. Hey, I mean, without 2020, I couldn't have gotten puppies. Not good. Well, wait, the good. What if my friend sent me an awful meme? 2020. Hope it was a mistake. I was like, that's pretty dark. All right, where is Wolfram Alpha? Oh well, I just have a new one. Boop, boop. History, Wolfram Alpha. All right. Wow. And so this is how you type it in. Okay. So what you do is you hit, I guess I'll retype it in live. So it's bracket, bracket. So that means to start a matrix, and then you're going to type it in row by row. And so in this case, the row is -3. Let me move me over a little bit so I can read -3, comma, -5, comma, 36, comma, 10. Then you close the row, and you hit a comma, and you open a new row, so bracket, -1, comma, 0, comma, 7, comma, 5, close the bracket, comma, open the bracket, 1, comma, oops, that's not comma, comma, 1, comma, -10, comma, -4, close bracket, and then we close the bracket to close the matrix. So when you're done with all your rows, you can close, and just enter. Make sure you typed it in right. All right, so we have it typed in right, and then we can just type in RREF. And so that means reduce row echelon form. So reduce row echelon form for RREF, your matrix. Wow. And if you have like a graphing calculator, it's the exact same thing you type in. All right. Okay, so here we have here's something went wrong. What went wrong? This should not end up with an answer. Hi, please notice what I did wrong. I did not put 36, I put 26. Because I know what the answer is, right? So that's why you do it by hand and do it in the calculator, because I type it in the calculator wrong all the time. Oh boy. I don't mean to do these things. It's just a walking example of what not to do. We all have purposes in life. Right? Thanks. Yes, I noticed I typed in 26. So here we get this. Right? So if we put it in we're going to get this answer. So here. And so I'm just going to write this down. So we could do this by hand, and that's fine, but I also want to say RREF. So through RREF, we get the following. So we have 1, 0, minus 7, minus 5, 0, 1, minus 3, 1, 0, 0, 0, 0. Okay, so once we do all this, and if you did this by hand, it only takes about 4 steps to get to this point. So once we're here, I was like, okay, so we have infinitely many solutions, right? This 0 says infinitely many. So let's write out what this means. This means x minus 7z equals to minus 5. This row says y minus 3z is equal to 1. This row says 0 equal to 0. So what happens in this case? We're just going to set z equal to z, right? I usually set it equal to t, but your book just sets it equal to z. So if z equals to z, we solve for y. So we're going to solve this one for y, or this is actually equation 2. Equation 1. Equation 3 has nothing really. So 2, I'll have 2 equals minus 3z equals to 1. Oops. Minus 3z equal to 1. We solve for y. We get y equals to 1 minus, or 1 plus 3z. And then for 1, we're going to have x minus 7z equals to minus 5. We solve for this. We have minus 5 plus 7z. And notice when we do reduced row echelon form, I don't have to worry about plugging in y because I've already zeroed it out. Okay? And I'll show you from my old notes when we did it by hand, and I'll show you by hand real quick when we end this. So let me write down the answer here. So it would be z. No, x is minus 5 plus 7z. Y is 1 plus 3z. And then we have z is our answer. So this is our answer. But let's see if I did it by hand, right? Let's just look at if I did it by hand. So if I did it by hand, so here's me doing it by hand. The first thing I want to do is swap these 2 rows, and so I did. So I got a 1 here, just because that's the easiest one to get is just by flipping rows. I got my 1 here. Then I want to make this 0 and this 0, so I'm going to add 1 here and 3 here, since these are already negative, right? So I get to here. This is already 1, so I'm good to go. And so I just want to put a 0 here, according to my algorithm. So I put in my 0 here. And when I put the 0 here, I just zero out everything, and I get infinitely many solutions. But notice here, I set z equal to t this time, right? And here I set z equals to 3 minus t. And so, and x equals to this. And so we get the same answer. But notice I didn't complete it. I didn't finish this. I didn't negate this row up to this row. And by not doing that, I had this extra step here where I had to plug in what y was, right? Because I still didn't fix this. I had to plug in what y was. I get the same answer, so it works out the same. Okay. So this is if you want to do it by hand. It's perfectly fine to do it in the calculator for now. All right. With all that being said,